So if you haven't watched the previous examples, it's a good idea to start with this one because this one adds an extra step because it's in basic solution instead of in acidic solution. So in this case, we have Br, which is -1. And over here, the Br is going to be Br plus 3 times -2 equals -1. So in bromate, the Br is the unknown oxidation state. Oxygen has an oxidation state of -2 in compounds, and the overall charge is -1, so it equals the overall charge. So it's 3 oxygens times the -2 oxidation state equals the overall charge. In this case, Br equals plus 5. So Br goes to plus 5. We've used permanganate several times before, and it's plus 7. And then over here, we have Mn plus 2 times -2 equals 0, because in this case, the overall charge is 0. We have the 2 oxygens with the -2 oxidation state, and this makes Mn plus 4. So now we have to identify oxidation and reduction. The bromine went from -1 to plus 5. This is going to be losing electrons, so this is oxidation. And the permanganate, the manganese, went from plus 7 to plus 4. This is gaining electrons, so this is reduction. So now I can write my half reactions. My half reactions are Br minus for oxidation yields, this is aqueous, BrO3 minus aqueous. And my other half reaction is going to be MnO4 minus aqueous yields MnO2 solid. All right, and this is for reduction. Now, in this case, it's going to be more complicated not only because it's in a base, but it's also going to be more complicated because both of these things have oxygens in them. So the first thing I want to do, or step 3, if you will, I guess I should write it that way. Step 3 is balance the masses. But we have to balance the masses in 2 steps. We have to do it as if it's acid and then make it base. Let me show you what I mean. So the first thing we want to do is balance out our oxygens. So we want to add 3H2O liquid to make these oxygens plus Br minus aqueous yields BrO3 minus aqueous. Then after we've done that, we want to balance out with H+. So in this case, we want to have 6 H pluses on this side, because that will balance out our 6 hydrogens. So before we finish this, what we need to check is, do we have the same number of each element? We have 1 bromine on each side, 3 oxygens, 6 H's, and 6 H's. But now this is in base, so now we need to neutralize this by adding 6 OH minuses, and by adding 6 OH minuses over here. And what we're going to end up with is 6 OH minus aqueous plus 3H2O liquid plus Br minus aqueous yields BrO3 minus aqueous, and then the 6 H pluses and the 6 OH minuses makes 6H2O liquid. Then we can go ahead and cancel out the waters. Since there's 3 on this side and 6 on this side, those all go, and we end up with 3 waters. So ultimately, we have 6 OH minus aqueous plus Br minus aqueous yields BrO3 minus aqueous plus 3H2O liquid. All right, so that is quite a lot of work just to balance the mass. Let's make sure that it works. So we have 6 oxygens, and we have 3 and 3 more, 6 oxygens. 6 H's, 3 waters is 6 H's, 1 Br, 1 Br. So we're good. Now we got to do the same thing with the reduction half reaction. So I'm going to write this for step 3 for the reduction way down here because I'm running out of space and I'm already telling you I'm going to need another piece of paper to finish this off. So when we do this, we need to first balance the oxygen. So we have MnO4 minus aqueous yields MnO2 solid. we need to add here 2 H2O liquids, because now we have 4 oxygens and 2 plus 2 more 4 oxygens. Once we have the 4 oxygens balanced, we need to add the 4 H pluses because we just added 4 H's, so we need to add 4 H plus aqueous over here. Just like before, this is in base, so we have to add 4 OH minus to this side and 4 OH minus to this side. So the H pluses and the OH minuses make water, so we get 4 H2O liquid plus MnO4 minus aqueous yields MnO2 solid plus 2 H2O liquid plus 4 OH minus aqueous. We can cross out 2 of these and both of those waters, and we end up with 2 H2O, oh, you guys can't see that, 2 H2O liquid plus MnO4 minus aqueous yields MnO2 solid plus 4 OH minus aqueous. Let's again check and make sure that it's balanced. So we have 4 hydrogens, 4 OH minuses, 2 oxygens plus 4 oxygens is 6 oxygens, 2 oxygens plus 4 oxygens is 6 oxygens, 1 manganese and 1 manganese. So now we have balanced successfully the masses. The next thing we need to do is to add the electrons. So I'm going to write down here step 4 is to balance out the charges. So in this case we have 6 minus plus a minus is 7 minus total. And over here we have 1 minus. So on this side we have 7 minus, and on this side we have 1 minus, which means that we need to add to this side 6 electrons. So that'll give us 6 minus, 7 minus, 1 minus, and 6 minus is 7 minus. Note that we want the electrons to be a product for the oxidation half reaction. For step 4, for the reduction half reaction, we need to have, hopefully the electrons will be a reactant. Let's take a look. We have a minus on this side and a 4 minus on this side, which means we need 3 E minus on this side. So that gives us 3 minus, 4 minus, yields 4 minus. Now we need to even them out. The good news is, for step 5, we only need to do it for this reaction because this is 6 and this is 3, so we can combine those two together by doubling everything here. So 6 E minus plus 4 H2O liquid plus 2 MnO4 minus aqueous yields 2 MnO2 solid plus 8 OH minus aqueous. So what we're doing is we're making the number of electrons from the reduction half reaction be equal to the number of electrons in the oxidation half reactions so that they'll cancel out. Now in this case, there's a lot of stuff to cancel out, so it's probably easier to just write all the reactants on one side and all the products on other, knowing that you're going to have to write the reaction twice. So for step 6, the first thing I'm going to do is write all the reactants of this one, which is 6 OH minus aqueous plus Br minus aqueous. Now all the reactants of this one plus 6 electrons plus 4 H2O liquid plus 2 MnO4 minus aqueous yields. I'm going to put the products on the bottom. All the products, BrO3 minus aqueous plus 3 H2O liquid plus 6 E minus, so I just wrote all these products. Now I'm going to write all the products for this one, plus 2 MnO2 solid plus 8 OH minus aqueous. Good. Now I can cancel out everything that's alike on both sides. We purposely made the electrons alike on both sides because we can't have the electrons in the reaction. Now let's see what else is alike. So on this side we have 3 waters, and on this side we have 4 waters. So essentially, we can cancel out all those waters and all but one of those waters. And what about OH minuses? On this side, we have 6 OH minus. Those can go, because on this side we have 8 OH minus, which will leave us 2 more OH minus. We can now rewrite the reactants, Br minus aqueous, okay, plus H2O liquid, plus 2MnO4 minus aqueous yields BrO3 minus aqueous, so I'm just removing everything that got canceled out, plus 2MnO2 solid plus 2OH minus aqueous, like so. Let's check it. 1 bromine, 1 bromine. 2 hydrogens, 2 OH minus is 2 hydrogens. 1 oxygen plus 8 more oxygens is 9 oxygens. 3 oxygens plus 2 times 2 is 4 oxygens. That's 7 oxygens. And 2 more is 9 oxygens. 2 manganese, 2 manganese. Good. Let's check the charges. -1 and 2 minuses is 3 minus. -1 and 2 minuses is 3 minus. So it is a tremendous amount of work, and needless to say, this takes a lot of practice, but this is balancing a redox equation in basic solution, where you essentially balance as if it's an acid solution and then add OH minus. Note that because both things have oxygens in the original equation, it becomes a mess, and there's a lot of stuff that gets canceled out at the end, and it just takes practice to work your way through these.